Hello, sixth graders. Mr. Smith here again, and this week we are going to review potential and kinetic energy. Energy, you need to know, is the ability to do work. It's the ability to move or cause change in matter, and there are two types of mechanical energy. You have potential energy, which is stored, not moving, it's just there and available, and you have kinetic energy, which is energy that is actually in use or moving. Potential energy is stored energy in an object due to its position. Notice the guy up here is very high, and if it were to fall, it would create a tremendous amount of energy, which would be kinetic as it's falling. It's ready to be used, but it's not being used. It can be transformed into other types of energies. The scientific unit is the joule, and the distance or height and its mass determine how much potential energy is available. Remember when we talk about potential energy, and in this case we're talking about gravitational energy, it's the amount of potential energy is determined by its height and its mass. The higher the object, the greater its potential energy. Like I taught the kids in my class, imagine that you are laying underneath two balls. Which one, if you had to choose, would you prefer to have fall onto your face? Obviously you would want the lower ball because it has less far to fall and will not hurt near as much. Therefore it has less potential energy. So remember that the higher the object is, the greater its potential energy. Additionally, if you were laying underneath two balls and one was big and one was small, which one would you rather have drop onto your face? Again, you would want the small ball to fall because it would cause much less damage than the larger or the ball with the more mass. Another type of potential energy is elastic. If you take this bow over here and you were to stretch it, well, that wasn't stretching it very good, but if you were to stretch it out and hold it, and if you notched an arrow in there, when you released it, its potential when it's being held and immediately becomes kinetic as you release the elastic band and it is set into motion. The amount of energy stored is related to the amount of stretch applied. The more stretch, the more stored energy. Again, think of it like rubber band. If I took a rubber band and pulled it halfway back and shot it at you, it wouldn't hurt. But if I pulled it all the way back and shot it at you, it might sting just a little bit more. Now let's talk about kinetic energy. This is the energy of motion. It's formed or caused by motion. It can be transformed into other types of energy. It is also, the scientific unit is also called the joule. The amount of kinetic energy is determined by its speed divided by its velocity and its mass. So how fast it's going, the direction it's going, as well as how much mass it has. The faster the object moves, the greater the kinetic energy. Think of it like a car. Let's talk about a car. If you're standing in the middle of the street and a car is stopped in front of you, it is potentially dangerous. That's potential energy. But if you're standing in a street and the car is going 30 miles an hour at you, it's going to cause a lot more damage. That's kinetic energy, and it has a lot of mass, the car does, and the speed is likely to kill you if you got into the street with a car, which is why we look both ways before we cross the street. Kinetic energy, the greater the mass, the greater the kinetic energy. Which ball has the greater kinetic energy? Greater kinetic energy? Again, that's going to be the bigger ball because it has more mass. Now a bouncing ball, there's going to be transformations. When it reaches its apex, when it's at the very, very top, it stops for a split second, and that's when the potential energy is at its absolute maximum, and because it actually stops there for, again, just a millisecond, but at that millisecond there is no kinetic energy because it is completely stopped. As it starts to go down, now the potential energy is decreasing because up here it had a lot more potential energy. Down here it's already lost half of its potential, and the kinetic energy is increasing because it is picking up speed. When it hits the ground, at the moment of impact, it has no more potential energy. The kinetic energy has reached its maximum. Now just a few seconds later, there will not be kinetic energy because it is stopped. But as the ball bounces and moves back up, it is now gaining potential energy because it's going higher and higher and higher, and it is stopped on the ground. There is no kinetic energy, but as it moves up, actually there's no kinetic energy. On a pendulum, when it reaches right here, that's the maximum it can go, and it stops. When it reaches that stopped point, it is at its maximum potential energy because it is no longer moving. The kinetic energy is actually zero, or it's at its minimum, until it starts to move again. As it starts to move and go back down, the kinetic energy reaches the maximum, or excuse me, the kinetic energy is increasing, potential is decreasing. When it gets to that very bottom point, that is when the kinetic is at its maximum, the potential is at its minimum. But as it starts to rise again, what's it doing? It's gaining potential energy. When it reaches point C, it's once again stopped up here. It has its maximum potential and it has its minimum kinetic. Again, that whole process starts when it goes back the other way. Kinetic is increasing, potential is decreasing, maximum potential at the bottom, and then once again increasing potential going back up. Same thing on a roller coaster. When you're stopped at the top, you have your maximum potential energy. It's 100%. When you are halfway down, just pretend when you get to that point, well, let me erase that because I'm writing right on top of the numbers. When it gets to the halfway point, imagine that it got jammed up. It's stopped. The potential energy, it's already lost half of it by going halfway down. But the kinetic energy, because it was moving, is at 50%. When it reaches the bottom, immediately kinetic energy is at 100%. It has no more potential energy because it's at rest at the bottom, but as it starts to move back up, potential energy starts to increase again, and it only went, if you talk about this being the highest point, this is the halfway point, and this is the quarter point. So that's why the potential energy at that point is 25% and the kinetic energy is 75%. Okay, again, if you're going, as you're moving, when it's at the very, very top, your potential energy is at its maximum, 100%. When it gets all the way to the bottom, your kinetic energy is at 100% because it's moved all the way down. Now over here, on this last one, the blue ball, its potential is 75% because it's moving up. It's going to be gaining potential all the way till it gets to the top. And your kinetic energy is at 25% because as it's moving up, it's losing energy, losing energy, losing energy. It's lost 25%, it's lost 50%, and up here it's lost 75% of its kinetic energy. It's about to come to a stop. Conversely, the purple ball, as it's going down, because it's moving forward, it's moving towards its maximum kinetic energy, which would be at the bottom. So there's your 50% there, 25%, and right now it's at 25%, or excuse me, 25, 50, 75% kinetic energy. It's lost 75% of its potential energy because it's almost to the bottom. When it reaches the bottom, it will have no more kinetic energy. And finally, let's do a little quick quiz. Decide if each situation is an example of kinetic or potential energy. Standing on the end of a diving board. Is that potential or kinetic? He's standing, he's not moving, so you're correct. That is potential. Falling from the top of a ladder. Moving, kinetic. A rubber band pulled back as far as it can go. Is it moving? No, it's been pulled back, but it has not been released, so it is potential energy. Water in a lake behind a dam. Just sitting there behind the dam, not moving, potential energy. Baseball just before it is released by the pitcher. It has not been released, therefore it has potential energy. Once it's released, it will become kinetic energy. You guys have a great week. All you need to do this week is take a little 15-question quiz, and you'll be done for the week as far as science goes. Have a great week. Reach out to your teachers if you have any questions. We are always here to help you, and anything you need, just ask. Thank you, and have a great week.